So for an equation of a circle, if I set h equal to 0, and I set k equal to 0, that will put my circle right at the center. Now, right now, I have r equals 1. So this is saying, so basically if h and k were 0, this would just say x squared plus y squared equals 1 squared. Now if I change that r value, I can change the size of my circle. The r stands for the radius. So if I want a radius of, let's say, 4, I put in r equals 4. If I want my radius to equal 3, I put r equals 3. Now, what's going to change here as I adjust these ones, the h and the k value, is it's going to change where the circle's centered at. So if I establish I want a radius of 4, so r equals 4, I can then move this around. So this one, the x should change my direction in the x direction. So if I move this, it should slide me left and right. Okay, so if my h value is, for example, let's go to 3, that means my center will be at x equals 3. So if I have x minus 3, then the center of my circle will be at x equals 3. If my y value, let's say we do y minus, let's just do y minus 1. Well, now the very dead center of the circle, they don't label the center of it, unfortunately, but the very dead center is going to be at x equals 3, y equals 1. So whatever these two numbers are, the h and the k value, they will correspond to the center of the circle. So h is going to be my x value at the center, k is going to be my y value at the center. Now that's only if I have minus h. If this turned around and was plus h, we would show up on the other side. So as what you kind of want to expect with equations and with doing transformations of equations is that when you, let me try to bring up a linear equation first. So if I said y equals 3x plus, well, let's just do 3x. If I want this line to move to the right, I need to say x minus 2. If I wanted that line to move to the left instead, I would say x plus 2. So if you add to the variable, if you add directly to the variable, that brings our whole graph to the left. If you subtract from it, it brings it to the right by that amount. Now with an equation for a circle, you just have that going on in two different directions. So let me get rid of these little sliders. Let's just put x plus 0, y plus 0 for now. And let's change this to 4 squared. So I'm going to take away all these little sliders, and we're just going to try moving them around. So if I wanted to move this to the left by 2 units, I would say x plus 2. If I wanted to move it up by 2 units, I would have to say y minus 2. Okay, so subtracting from y will move it up. Adding to y will move it down. Okay, so that's just generally how the different spots on this will work. This position, which was our h position, will move us left and right. Our k position moves us up and down. And our r value determines what the radius of the circle is. Now let's go through and kind of make sense of why those equations work out the way they do. So let's do x plus 2, and let's just do x plus 2 plus y squared equals 4 squared. Okay, so whenever I see something like this, x plus 2, my first thought always goes to, what if x is negative 2? Okay, that will simplify the equation down a lot. So if x was negative 2, then we'd have negative 2 plus 2 equals 0 squared is just 0, right? So when x is negative 2, so when we're along this vertical line right here, so all of this line is x equals negative 2. Now our equation defines this shape of the circle. So we are at negative 2 when we're up at this point and when we're down at this point. So there's 2 points that are at x equals negative 2. There's negative 2, negative 4, and there's negative 2, positive 4. Okay, well, for those two locations, the reason why we get those two locations is because when I have my equation, when I have x plus 2 squared and y squared equaling 4 squared. If I put in a -2 here, so that the whole first part goes away, we just get 0 squared. Effectively, that will simplify my equation to y squared equals 4 squared. Well, there's two answers for that. Y could be 4, right? 4 squared equals 4 squared. Or y could be -4, because -4 squared is 16, just like 4 squared is 16. So basically, we get two solutions for y when we plug in a value for x. So with a linear equation, typically it's you plug in a value for x and you get out one answer for y. For the equation of a circle, every location of x, at least within the domain of this circle, so from if I plug in a 2, a 1, a 0, a -1, -2, -3, -4, for almost all of these values, I'll get two different answers. So for example, if I put in -3, I should get out, like for y, it'll either be 3.87 or it'll be -3.87. Now, the only locations that would give me one output would be the two sides of the circle here. So -6 only gives me one output, and +2 only gives me one output. But anything between -6 and +2 will have two different y values that'll work. If you think about it in the opposite direction, if I was to plug in a y value first, so like, let's say I just chose y to be 2, well, then there's only going to be two solutions for x that work. If y was 2, then x could be like 1.5, it looks like, or it could be -5.4. So on this one, those two values, the -5.4 and the +1.4, they weren't equal in magnitude because the circle's been shifted over to the left. In the other case, where we went from like, okay, on this one, when we're at -4, we're at like 3.47, and we're at -3.47, those two were equal and opposite because we had not shifted up or down in the circle. We'd only shifted to the left. Okay, so you can kind of play around with that and put in different numbers and see how this all works out. One thing to notice, though, is that if you take any location along this circle, so like let's say this point, which has some coordinate x and y, and we've got the center here. If you turn this into a right triangle, and you call this our radius, then we know that the equation that connects these things, so let's say this is at 0, 0, right? This is at the origin right there. So whatever this distance is, we'll call it x. Whatever this distance is, we'll call it y. And we know from that Pythagorean theorem would tell us that x squared plus y squared should equal r squared. And that is, in effect, our definition of a circle. We do x squared plus y squared equals r squared. Now, the size of r is not a variable in these equations. R will just have some number. The size of r will determine the size of our circle. So if r, for example, is 3, then we have a radius of 3. And it doesn't matter where we are, what point we're looking at along the outside of the circle, the radius is always going to be 3. So what we're kind of working with, which is actually related a lot to trigonometry, is we're kind of working with something that looks a lot like what we call the unit circle in advanced trigonometry. It's like we have a circle, and then we're just looking at the left side. Don't worry about this stuff over here on the right. But on the left side, we've got a right triangle that's inside this circle. So whatever coordinate we're at along the outside, so like on the outside here, right where my mouse was, would be the coordinate 0.6, 0.78, right? This would be the coordinate -0.75, 0.65. Whatever those coordinates are around the outside of the circle, they're all going to have to do with a right triangle. And that right triangle should follow Pythagorean's theorem. So we should be able to draw out this picture. Now, the reason why we have this like x, minus h, and y minus k situation going on in like the full equation is that we're not always centered at 0, 0. So this one only works if we're centered at 0, 0. Let's say that we are located, the center of our graph is at like, let's say this one's 3, 4. Let's give it some center. So in that case, our coordinate right here would be 3 plus x. And our y coordinate would be, 4 plus y. Okay, and once we've adjusted those coordinates, we end up seeing that these, we need to have these parentheses with these adjustments in them with the, plus some amount, plus 3 or plus 4. We'll see that when we get to an actual problem on it, so we'll just wait to go into detail on that point. So let's go through and let's start looking at the actual problem and see what they give us. Okay, so for a lot of these, they want us to identify the center and the radius. So keeping in mind, our general equation is x minus h squared plus y minus k squared equals r squared. So first thing to say is that 4 would not be our radius. 4 would be our radius squared, which means our radius should just be 2. Over here, we h and k are going to be the center of the circle. But in this case, we don't have minus on both of them. So for this one, minus 2, that works. So the k should be 2. But for the h, we have x plus 1. So if we were going to put it in this form of x minus h, that would have to be x minus negative 1 in order to have it say x plus 1. So our h value is not positive 1, it's going to be negative 1. Another way to think of that is, like we said before, if we're adding to the x value, we're moving to the left by 1 unit. And if we're subtracting from the y value, we're moving up 2 units. Okay, so we find our center, and then we create a radius of 2. So what is my center? Negative 1, comma 2. Okay. So your center is based off these two values. It's just going to be the opposite. So if you have plus 1, it's going to be minus 1 for the x. And if you have minus 2, it's going to be plus 2 over here. And then the radius is just going to be the square root of what's over here on the right side, because the right side is r squared, and we just want the radius by itself. So we want the square root of whatever is over here on the right, which in this case would be 2. So let's check this one. Okay, so that looks all good. There's a process that we saw before at the very beginning of the year when we were doing our quadratics unit, which was called completing the square. So completing the square is when we have something that we want to factor into a perfect square. So like u plus something times u plus something. We want it to have the same thing on both sides. So for example, if I did like u plus 3 times u plus 3, that would give me, well, it wouldn't give me this, first of all. So let me kind of break this down for a moment. When we complete the square, what we tend to do is we take what was given to us and we put it in our area model. Okay, so we say we have u squared. Right now we have 0 right here, and we have 6u in between these two boxes. So I'm going to put 3u in each of them. Okay, so if I wanted to turn this thing into something squared, it would have to be u plus 3 times u plus 3. However, I wouldn't have a 0 here if that was the case. I would have to have a 9 here. Okay, so that means that that's what they're looking for. They're looking for that 9 there. They're looking for whatever number you need to add to this to generate an area in here that is a perfect square. That has the same thing on the top as the side. Okay, so that means that if we have this thing, u squared plus 6u plus 9, that is equivalent to u plus 3 times itself. So u plus 3 squared. That's what it means to make this into a perfect square. We need to add the missing piece that would allow us to arrange this stuff into a perfect square area model. Okay, that's going to be a necessary skill on some of these upcoming questions. I think on this next one, actually. Yep. Okay, so let's see how that plays out with this actual problem here. So they give us kind of a mess of stuff, and they want us to put it into that standard form. Okay, so first of all, I'm going to put my x's together. And I'm going to move that 4 to the right side. So I'm going to add 4 on both sides of the equation. Get rid of the negative 4 and get a 4 onto the right side. Now, after that, what we're going to do is what we want, as a reminder, we want something like this, x minus h squared. We want this whole thing written as some quantity squared. Now, at the moment, it is not some quantity squared. So there is no way that I can get x squared and 4x into a perfect square area model. However, if I do that tactic of completing the square, then I can. So what I mean is this. So we're going to put x squared in here. We currently don't have any number for that bottom right corner, but we have 2 x's here and we have 2 x's here, which means that we're looking at the area model for x plus 2. Okay, which means that bottom right one, if it was x plus 2, that would need to be a 4. Okay, so we say that x plus 2 squared equals all of this stuff on the inside. So now here's what we do. Let me make this a little bigger. We want to get this into our equation, but the only way we can put that in is if we have that extra 4 that is not currently in there. Ooh, that's not what I want. Okay, so we need that extra 4 to be in there. Well, if we want to add that extra 4 in there, if I want to say x squared plus 4x plus 4, that's fine to do as long as I add an extra 4 on the right side. The y squared minus 2y, that's not going to change yet. But on the left side of my equation, I've added a 4. On the right side, I've added a 4. And adding that 4 allowed me to complete the square. Right? It allowed me to get this written in terms of something squared. Okay, now we just want to do the same thing for the y portion of the equation. So in the y portion of our equation, we've got y squared and we've got negative 2y. So putting that into an area model and completing our square will look something like this once my computer stops glitching out on me. Okay, so we are going to have y squared. We're going to have a negative y and another negative y, which means we have y minus 1. If we did negative 1 times negative 1, we would have a 1 down here. So in order to write out y minus 1 squared in our equation, we're going to have to add that 1 in that is not currently in there right now. So this part in the front will stay the same, x plus 2 squared. We are going to add 1 to the left side, and we are going to add 1 to the right side. Now that allows us to rewrite this portion as y minus 1 squared. So we're going to have x plus 2 squared plus y minus 1 squared, and that will equal 9. Okay, so now that we have gotten it into our standard form, we should be able to kind of put this circle down on our graph. So first of all, keep in mind that this whole thing should equal r squared, so our radius would have to be 3 in this case. If r squared is going to be 9, then our radius should be 3. Our center should be based off these, so we're going to take a circle. We're going to move, so based off this one, plus 2 will mean 2 units to the left for the x, and minus 1 will mean 1 unit up in the y direction. Right, we want to do that, and we want to have a radius of 3. Okay, so just remember, we always go the opposite direction of kind of like our, probably what is my intuition anyways. I see plus 2, I think of plus 2 as in, all right, go to the right 2. But plus 2 actually means in the x direction, we're going to go to the left by 2. Minus 1 means we're going to go up by 1 in the y direction. Okay, and the radius squared is 9, which means the radius is 3. Okay, so that all looks good to me. So we can go with -2, +1 as the center of our circle, and give that a try. Okay, good to go. Okay, so this one's going to give us more of a word description. So they say, give the equation of a circle centered at the origin passing through the point 0, 8. So if it is centered at the origin and it passes through the point 0, 8, then we're looking at a circle like that, where the x squared part is not going to have a plus or a minus because we're not shifting our circle to the right or left. It's centered on the origin. The y squared part will stay like that as well. Well, let's just think about, like, if we're over on this point, our x value is going to be 8, right? So we'll have 8 squared, and our y value is going to be 0. So just thinking about, labeling this point right here, 8, 0. Our x value is being squared, so we have 64 plus our y value squared, but our y value is just 0, so we're not really adding anything. So it should just equal 64. If we did the same thing at any other point along the circle, like up here at x equals 0, y equals 8, we do the same thing. So we'd say x squared would be 0 squared, y squared would be 8 squared, and together they make 64. If you want to go over here to the negative side, we could say -8, 0. Well, -8 squared is still 64. Y squared is still going to be 0. And when we add them, we'll get 64. Now, this is easiest along those 4 kind of quadrant dividers, those 4 90-degree rotations. It's a little harder if we pick like some random spot along the side here. But for any number, there will be a solution. So like if I did, let's just say I want to go over to 7. Okay, so we know that there's got to be a point at x equals 7 because there's points along from, or sorry, -7. My bad. There's points all the way along this, right? -8, -7, -6, -5, -4, -3, all the way to 0, all the way up to 8. Anything between -8 and 8 should have some solution on this circle. If we wanted to look for -7, well, then we'd just go into our equation. We'd say x squared, so we'd have -7 squared plus y squared. We don't know the y value at this location, but this is what we'd be figuring out, equals 64. Well, in that case, we've got 49 and y squared equals 64. Y squared would then be 15, and y would be the square root of 15. Okay, so we'd get some value for that y coordinate by just kind of plugging in the x coordinate into our graph. So this point would be like -7, comma, square root of 15. Now, if you kind of pay attention to the types of things that we did here, we basically just had a right triangle, right? We had this right triangle right here, where we had a squared plus b squared. A was our distance here, -7. B was the one that we were trying to figure out, which we called the y coordinate. And then our c squared was our radius squared, right? That's that part right there. Well, we know our radius to be 8, so that number squared would be 64. So the equation that we solved in order to get that coordinate was just Pythagorean's theorem. Even when we move on to circles, you can't escape from those right triangles. They're just everywhere. Okay, so now they say consider the circle centered at the origin. So once again, we're at the origin and going through the point 0, -2. So it looks like it's going to have a radius of 2. Right, we are centered at the origin, and we go through 0. Oh, sorry, 0 in the x direction, right? So we go through down here, 0, -2. So we have a radius of 2. So we are going to say x squared plus y squared equals the radius squared, 2 squared, or you can just call it 4. Now they want to say, are these following coordinates part of the circle? Well, if they plug it in, they work, then we're in good shape. So for this one, x squared would be -2 squared, so that'd be 4, and square root of 3 squared. Well, when you square a square root, right, square root of 3 squared, that just gets rid of the square root symbol. So square root of 3 squared is 3, just like any other square root squared gets rid of it. So if I had square root of 4 squared, that would be 4. Okay, so I'm just thinking we're going to square each of these values and add them. So we're going to get 4 and 3. We'll add them and get 7. That's not going to be on the circle. We need to add and get to 4. 0 squared is 0. 4 squared is 16. But 16 does not equal 4, so that's another no. This guy, we get 4 plus 0 when we square these two and add them. So that does give us 4. And this one, we get 5 and 9, which would give us 14. So I think the only one that's going to be on the circle, the only one that actually fits when I put them into the equation, is that third option on this on my example. I've looked at other examples where almost all of them were on there. For that example, just that one. An equation of the circle with a center at 3, -6, and a radius of 9. So we're going to have x minus h plus y minus k, both those squared, equaling our radius squared. Well, it says the radius is 9, so we know that at least this part should be 9 squared, or 81. Beyond that, we just want to get our h and our k values correct, so that we have the correct center. So if we want to go in the x direction, we want to move to the right by 3 units. We want to be at +3. That means we need a -3 here. If we want in the y direction to be centered down 6 units, so down at -6, we're going to have +6 right here. Okay, so we should have the equation x minus 3 squared plus y plus 6 squared equaling 81. That should do the trick for us. Okay, let me go over to Desmos for just a moment for that one. Just want to kind of compare that to looking at it on a graph. So if we do x minus 3 squared, y 6 squared, and have that equal 81, then what do we get? We get a circle whose center is at 3, -6. So is that correct? 3, -6. That looks right about in the center to me. And it has a radius of 9. So it goes from here out to the edge is 9 units. That looks good. So now just to kind of reaffirm this, if I wanted it to be moved If in the y direction I didn't want it at -6, I wanted it up at +6 for the middle, then I would have a minus sign here. All right. I wanted, instead of it to be at x equals +3 for the center, if I wanted it to be at x equals -3, if I wanted it to move to the left rather than the right, I would have put a plus right there. Okay, so it's good to get in here on Desmos and kind of just play around with these and see what happens when we change any part of that equation. There's kind of those three parts that we can change: the h value, the k value, and the r value. Okay, this problem is going to kind of break down how the Pythagorean theorem is closely related to what we're doing. So on here, they ask for the radius. Well, I see a radius of 2 units. The center is at 4, 7, based off the axes here. 4 and 7. The value of a right here, well, that is going to be, what is that going to be? They're saying this is the point xy. Right, here's the point xy. So this distance right here, well, let me draw this out on a graph real quick. Okay, that center is at 4 and 7. And they're saying that this point up here is called xy, which effectively means that, like, right here we would label x, and right here we would label y, right? So if they're asking for us the value of a, they're asking for this little distance right here. Well, it's just the distance between 4 and whatever that x value is. We don't know what the x value is, but the distance in between could just be called the difference. So I would write that as x minus 4, right? This whole distance of x minus the distance of 4 gives me the difference between the two. So I'm going to call this guy, oops, I call this guy x minus 4. And in the other direction, we have a total distance of y that we're going to take 7 away from in order to get the length in between, which means we are going to have y minus 7 for my other side. Okay, so let's put those in. Value of a should be x minus 4. Value of b should be y minus 7. Okay, now they're saying write this out as Pythagorean theorem. So a was going to be my x minus 4 squared. Pythagorean theorem being a squared plus b squared equals c squared. So my a is x minus 4, my b is y minus 7, and my c is 2, right? It's that hypotenuse. Okay, and that is that is a different way of kind of generating some intuition for why we have this like x minus 4 and y minus 7. It's just based off the fact that if the center is located at some position, then in order to figure out the length of these two portions, a and b in here, you have to take whatever this coordinate that you're on and subtract off that 4 in the x direction and that 7 in the y direction to figure out how to express these two lengths, a and b. So we express them as x minus 4 and y minus 7. Okay, circle has a center at -2, 2, so let's just start with that part. So we're going to have, we want to go to the left by 2 units, so we're going to say x plus 2 squared. And we want to go up by 2 units in the y direction, so we're going to say y minus 2 squared. Now the last part is to get the radius correct. So it says it passes through 6, -4. So if I am at -2, 2, and I pass through 6, -4, something like this, then from the center to the edge of my circle, right? We're saying this is going to be a big circle. From the center to the edge of the circle, my radius, it would be my radius. My radius is going to be the hypotenuse on a certain right triangle. So it's the hypotenuse on the right triangle that goes from, well, in the y direction, it goes from 2 to -4, so it has a length of 6 right there. And in the x direction, it goes from -2 to +6. So it has a length of 8 in that direction, right? I'm labeling this length, labeling that length and that length of my right triangle, 6 and 8. Okay, well, if I want to get my radius then, I should be able to say that 6 squared plus 8 squared equals r squared. So 6 squared is 36, 8 squared is 64, and my r squared ends up being 100. Okay, and that's what I want, right? Because my equation for a circle is always x minus h squared y minus k squared equals r squared. So we want the full r squared value over there on the right side. So we want that 100. We don't need its square root. We just want equals 100. Okay, good. Last question for the last homework assignment of your last quarter of this class. Coming up, find an equation of a circle whose diameter has endpoints at 5, 4, and -3, 2. Okay, so 5, 4, and -3, 2. So we're like 5, 4, something like that. Oh, why am I on a highlighter now? What happened there? And -3, 2. Okay, well, if that is the diameter of our circle, right? We've got some circle here, and that is the diameter. Then the center, which we need for our equation, should be right in between the x coordinates, and it should be right in between the y coordinates. So if I have -3, 2 here, well, right in between the x coordinates, there's a distance of 8 separating these two. So halfway in between would be if I moved over by 4, right? So like 1, that is 4 bigger in this direction and 4 smaller in that direction. So it's right in the middle. Right between 4 and 2 is obviously going to be 3. So our coordinate here should be 1, 3. That should be the center of the circle. We also want to figure out what the radius is. So I'm just going to pick one part of that. If I'm going from 1, 3 to 5, 4, then I have a right triangle that has a distance of 4 in this direction. 1 to 5, distance of 4 in that direction, and a distance 1 in the vertical direction, right, from 3 to 4. Using that, I can say that my equation is going to look like 4 squared and 1 squared add up to make r squared. So r squared value is going to be 16 and 1, so 17. So once you've got your center and you've got your radius squared, you can put that together into the equation. So I want the center of my circle moved to the right by 1. So I'm going to say x minus 1. Right? In order to move it to the right, we have to do minus. And y, we're moving up by 3, I think. Yep. Y minus 3. Those two things squared should equal our radius squared, which was 17. Okay, well, that is it. So that is it for this assignment, for this topic, for this unit, and for this year. That is it. We will, like I said, we will spend the remaining time in class for the next 3 weeks working on just general review, general catch-up, whatever you guys need. And I look forward to seeing you guys then and there next week in the class.